Welcome back to The Explainer. So, what if I told you there's a blueprint out there that doesn't just dream about traveling to the stars, but actually lays out a practical, engineering-based path to get there? Yeah, today we are diving into a concept that could literally rewrite humanity's future in the cosmos. You know, for all of human history, the stars have been right there, so close in the night sky, but just impossibly far away. The universe is just so unbelievably vast. It's like we've been trapped in our own little solar system. But what if there's a key we've been missing? I mean, just to put this into perspective, our fastest rockets today would take over 100,000 years just to get to our nearest neighboring star. That's not a journey, that's an ice age. But here's the thing. What if we've been trying to just brute force the door open when we should have been looking for the lock? What if a totally new way of thinking could make that same trip, well, instantaneous? All right, so to really get why this idea is such a game changer, first, we've got to look at why all the classic sci-fi ideas for zipping across the galaxy have always hit a massive brick wall. Think about all the classics, right? Warp drives, stable wormholes. They all slam into the exact same problem. They need one of two things that are basically impossible. Either the energy output of an entire star or just massive amounts of something called exotic matter. We're talking about theoretical stuff with weird properties like negative mass that we've never found and honestly probably doesn't even exist. So this new concept, it takes a completely different path. It doesn't try to punch a hole through space-time. Nope. Instead, it suggests we can find a natural pathway that's already there. And the key to finding it, and this is the wild part, comes from watching what happens when you place sounds at a pile of sand. Okay, so this principle is called cymatics. It's pretty cool. If you vibrate a plate that's covered in sand with just the right frequency, all those chaotic little grains will suddenly just snap into these beautiful, stable, geometric patterns. You're creating perfect order out of total chaos just by using the right vibrations, the right resonance. Okay, now here is the giant leap. The theory is that this isn't just a neat trick with sand, it's a universal principle. The same physics that explains how sound waves can create a stable node in sand, well, it can be scaled up to the quantum level. So if you swap out sound waves for precisely timed quantum pulses, you could, in theory, create a stable node not in sand, but in the fabric of space-time itself. And that stable point, that becomes your traversable wormhole. It's basically a three-step process. First, you get a ring of plasma spinning like crazy to create a little vortex in space-time. Then, 15 different emitters fire perfectly synchronized energy pulses right into that vortex. And finally, the interference pattern from all those pulses collapses from chaos into a single, stable geometric point. And bam! That's the throat of your wormhole. Okay, that's amazing. But it brings up a huge question, right? If you can just open a door in space-time, how on earth do you tell it where to open? How do you actually navigate this thing? Well, think of it like you're tuning a cosmic radio. The system starts with a frequency we know really well, Earth's own natural electromagnetic pulse, which is called the Schumann resonance. That's kind of like station 0 on the dial. From there, it tunes up, jumping through very specific harmonic frequencies until it gets a lock on the unique energy signature of the star you're trying to get to. That resonance lock is what creates the connection, the entanglement you need to make the jump. But there is a catch. Of course, there's a catch. And it's a terrifying, seemingly fatal flaw hiding inside this incredible technology. While the physics of the jump itself might work, for any person on board, the experience would be, well, instantly lethal. The problem is the acceleration. Because the jump is instantaneous, the effective g-forces on the crew would be 1 quadrillion times the gravity of Earth. That's a 1 with 15 zeros after it. It's a number so huge it's hard to even wrap your head around. And look, we're not just talking about discomfort here. An acceleration of 1 quadrillion Gs would tear apart steel, rock, and absolutely the human body, atom by atom. It really seems like an absolute, totally insurmountable barrier. So the solution is just this incredible piece of mechanical engineering. It's called the Matryoshka rotational shield. And yeah, you should be thinking of those Russian nesting dolls all nested inside each other, but spinning at unbelievable speeds, with the crew tucked safely right in the middle. This shield is just a masterpiece of physics. It protects the crew in two brilliant ways. First, the incredibly fast-spinning shells actually warp the flow of time inside, making time run about 1,000,000 times slower. So for the crew, it stretches that instantaneous jump into a slightly longer, more manageable event.
At the same time, a central core spins in the opposite direction, acting like a super powerful gyroscope that physically cancels out those crushing acceleration forces. Put it all together, and it takes an unsurvivable event and brings it all the way down to something that can be handled with special flight suits.
Now, I know this might all sound like something from a far future sci-fi movie, but the team behind this idea has laid out a concrete, step-by-step plan to turn this from a wild theory into a real engineering project. And what's so crucial here is that this isn't just some wild idea. It's a testable, falsifiable theory, meaning they can actually build experiments to see if it works or not. The plan starts small, with just a simple tabletop device to prove the core cymatics principle. From there, it scales up, leading to a prototype that could actually measure the warping of space-time, with a target for the first unmanned test flight around 2040. And maybe the most surprising thing about all of this is the cost. That initial proof of concept phase, the one that could prove the fundamental physics actually works, is estimated at just $50,000. The entire validation program, from the little model all the way to the SHIELD prototype, costs less than the budget of a single Hollywood blockbuster. And this quote just captures the whole shift in thinking perfectly. The team behind this isn't just lost in some theoretical fantasy. They are laying out a real roadmap, turning what seemed like an impossible physics problem into a series of incredibly difficult but ultimately solvable engineering challenges. So by completely reframing the problem, from one of brute force to one of resonance, this blueprint presents a credible path to the stars. And it leaves us with this one profound question. If interstellar travel stops being a matter of if and starts being a matter of when, what happens next? What does that mean for all of us?